Hello. Today we're going to work with how to simplify trigonometric expressions, specifically using the three Pythagorean identities and the basic definitions of tan, secant, and cosecant. Let's go. Okay, here's our first problem today. Now, I have to admit, I find these so fun. They're like puzzles to unwrap. But a lot of students get really strung out about how to even begin. So let me just say there are two things that I'm going to look for how to begin. The first is, do I have any squared terms? And the answer is yes, I do. And if I have squared terms, then I know I'm going to wind up using my Pythagorean identities. I'm just going to write these in the corner for you to remember. Now, if you don't have these three committed to memory, that's your next task. Memorize these. Okay, so the other thing I look for is, do I have tangents or secants or cosines, in which case I can convert them all back to sines and cosines. And again, let me just write those out for you. And for sure, if you don't have these committed to memory, pause this video right now, go check out this other video and memorize them. All right, so now back to the problem at hand, whale. I see that I've got a tan squared x. So I know I have an identity using it, but I'm not sure that a secant squared x is going to help me that much more. So instead, I'm going to choose to convert it to sines and cosines. So my first step might look like this, where I've just converted my tan squared x into sine squared x over cosine squared x. Well, now I see I have cosine squared x times something over cosine squared x. Those are going to cancel, right, if I put that over 1. Now, just to remind you, all the rules of algebra still apply, so I'm not involving this because I've got a plus there. These are not the same term, but I've got a multiplication in there, right, cosine squared, and there's nothing there, that's implied multiplication. So that's why I'm canceling those, but I'm not touching this yet. So when I finish that step, I'm left with cosine squared x plus sine squared x. Well, sine squared x plus cos squared x equals 1, and I can write addition any way I want to. So the simplification of this is just 1. Yay! Okay, let's do another. Sine to the fourth x minus cosine to the fourth x. Wait, what? We've got squareds. We don't have to the fourths. What's happening? Yes, I understand. Relax, we're all good. What I do see is that I have something to an even power minus something else to an even power. This is a difference of squares. Sine to the fourth x could be rewritten as sine squared x squared. And cos to the fourth x can be written as cos squared x squared. And in a difference of squares, I know my factorization, do you? Here we go. Sine squared x plus cos squared x times sine squared x minus cos squared x. Okay, sine squared x plus cos squared x, that's 1. 1 times sine squared x minus cos squared x. So I'm done, right? Wrong. What do I have here? Another difference of squares. Sine x minus cos x times sine x plus cos x. Okay, let's do one more. How do we begin this one? We've got a squared term, so we could look to our Pythagorean identity, and we have a cosecant, so we could look to convert to sines and cosines. Let's do both. 1 minus cos squared x. Okay, when I look at my Pythagorean identity up here, I see that if I subtract that cosine squared x to the other side, I get 1 minus cos squared x. And what does it equal? It equals sine squared x. So I'll do that substitution. And I know that my cosecant is 1 over sine x. So I know that if I were to multiply these two together, I get sine squared x over sine x, which simplifies to sine x. So those are 3 great examples of how to begin to simplify using your trigonometric identities, and specifically how to note when you have a squared term, you're looking to these first 3 formulas. And whenever you have a tangent, secant, or cosecant, you have the option to convert and make everything sines and cosines to then use your big fat algebra skills and simplify. All right, leave any questions you're struggling with in the comments. Consider subscribing to my channel so you know when I put out a new video. And as always, keep on mathing.